Hi, we're live here at the second RISC-V Summit, and this is Sandro.
Hi there.
With Hex Five Security.
Yeah.
And so, Sandro, tell me about the demo that you've got going on here. This is pretty cool.
What we are showing is security through isolation.
Security through isolation.
Yeah,
okay.
It's the concept of containers,
Yes.
like Dockers on the server space, but
Yes.
specifically on the embedded side.
On the embedded side. Yeah.
So what we are demoing here is two completely isolated zones that
Yes.
are exercising some of the functionalities of the system.
Okay.
One zone is running a DAM terminal, another zone is basically handling with some interrupts, some buttons, and the other zone is operating the robot.
Very cool. And then this has got a robot here.
I will put the robot
Awesome.
operating.
Awesome. Okay, so you've sent an instruction through the terminal to the device in one of the isolated areas of the trusted execution engine.
Yeah.
And explain why it's actually useful to have all this isolation between different functionality into the processor itself.
Yeah, because typically we are in the IoT era, right? We are living the IoT movement, and typically you connect your device to the internet.
Yes.
And what you see around is basically everything is mixed on a single memory space.
Yes.
If one application is compromised, for example, the TCP/IP stack that is connected to the internet, it basically gets down all of your system.
Yes.
What we have here is we put every single piece in every single container.
Yes.
If you screw with the TCP/IP stack, you cannot propagate your
Completely
faults
isolated and firewalled.
Exactly.
So basically each instruction could be isolated in its own memory space.
Exactly. Basically.
And how hard is it to actually break into one of those other memory spaces on the chip?
It's basically impossible as long as the hardware is not flawed, because it's a software-defined, hardware-enforced separation.
Wow,
So
that's complicated. Explain software-defined, hardware-enforced operations.
So
simplify that for the
you
world.
basically have some.
I understand it.
You have some hardware primitives that you can, while other technologies, you just rely on the hardware. You don't have the flexibility. If you need 4 zones on a moment and you need 8 zones in another different system, you need to do a new chip.
New chip.
Yeah, you need to follow the development process of a new processor. With this technology, we can provide some software flexibility so that the system designer, if you want to have in some point in time 4 zones, can have it. If 5 minutes later you decide that, oh, I need 8 zones and not 4, you can do it very easily and flexible.
So traditional CPUs without this multi-trust execution layer for sort of the processor instructions would have to have a completely separate chip to provide the same level of security isolation.
Exactly.
Is that a fair way of?
Yeah, it's fair to.
Okay.
Say
Okay.
like that.
And so. What is the necessary requirement to make this possible on IoT devices? Is it RISC-V or is it something else?
Yeah, it's the good thing or the beauty of this model is that we just rely on the hardware primitives available on standard RISC-V ISA. So we don't need any special hardware. It's there, it's available. You just make good use of them.
So this is based on the RISC-V ISA, and RISC-V is an open standard instruction set for building custom cores. In the cases of embedded IoT style devices, this is very valuable because people want to build a custom core for saving space, energy, size of the instructions on a chip.
Yeah.
And further, when you want to have this sort of high level of efficiency at the core design and also extremely rigorous security in terms of these instructions, you have Hex Five and the MultiZone Security layer available to you.
Of course, if you have more hardware primitives, you can optimize even more your system, but the really ones that are needed are on the ISA itself, and we take advantage of that.
As a hardware designer, how do I take advantage of this MultiZone Security technology? Is there a GitHub repo I can go to, or on the website?
You can basically go to GitHub, follow Hex Five. You go to GitHub, you can download all the SDK. You can download also a standard RISC-V core implementation that we have extended a little bit to implement the so-called MultiZone IoT stack.
Yes.
And you can basically try by yourself.
That's very cool. Awesome. Thank you so much for this conversation demo, Sandro.